Hello class 10. Let's solve the exercise of triangles of NCERT book. Exercise 6.1. In the fill in the blanks, number 1, all circles are similar because they have same shape but the radius are different, so the size is not always equal. Number 2, all squares are similar because of the same reason the length of the sides are always not equal, so they are not always congruent. Number 3, all equilateral triangles are similar because all the equilateral triangles have the same angle, that is 60 degree. All its angles are 60. So all the equilateral triangles are similar because all their angles are equal. Number 4, two polygons of the same number of sides are similar if their corresponding angles are equal and their corresponding sides are proportional. It is actually the main criteria for similar triangles. Number 2, give two different examples of pair of similar figures. So obviously any object having the same shape, like coins, same coins, 2 rupee coins, 3 rupee coins, okay, any notes, any 20 rupee notes, anything will be fine. Number 2, two examples of non-similar figures. Non-similar figures would be something which is having different shapes. So we can take a coin and a note also. Number 3, state whether the following quadrilaterals are similar or not. Obviously, we can see from the diagram that the second diagram has all its corners or vertices as 90 degree. But for the quadrilateral PQRS, the angles are not 90 degree. Since the angles of the corresponding sides are not equal for the two polygons, therefore we can say they are not similar figures. Exercise 6.2, here we will solve the sums using basic proportionality theorems. In figure 1, it is said that DE is parallel to BC, so we have to find EC. To find EC, we can see that DE is parallel to BC. So here we can apply the basic proportionality theorem. So by basic proportionality theorem, we can easily write AD by DB is equals to AE by EC. Now the values of AD, DB and AE is given as 1.5 centimeter, 3 centimeter and 1 centimeter. Only EC is unknown. We'll put the values in the equation and finally we're getting the value of EC as 2 centimeter. In the second question, again we have DE is parallel to BC. So we can apply the basic proportionality theorem here. Here the value of AD is unknown, so we have to find it out. DB, AE and EC is given as 7.2 centimeter, 1.8 centimeter and 5.4 centimeter. So we'll put the values and ultimately we'll calculate the values and it will be come out as AD is equals to 2.4 centimeter. Question number 2. E and F are points on the sides PQ and PR respectively of a triangle PQR. So let's draw a diagram. So we have a triangle PQR where E and F are 2 points on two sides of PQ and PR. For each of the following cases, state whether EF is parallel to QR. So number 1, the values are given. PE is equals to 3.9, EQ is equals to 3 centimeter, PF equals to 3.6 centimeter and FR is equals to 2.4 centimeter. Using the basic proportionality theorem, we will find out PE by EQ. So PE by EQ is equals to 3.9 by 3. Ultimately it's coming out as 1 by 3. And we will also find out PF by FR on the right hand side. So it is coming out as 1.5. By the theorem, both the ratios should have been equal. But since the values are coming out as 1.3 and 1.5 which are not equal, therefore we can say by basic proportionality theorem, EF and QR are not equal. In the second question, PE is equals to 4 centimeter, QE is equals to 4.5 centimeter, PF is equals to 8 centimeter, and RF is equals to 9 centimeter. Similarly, we'll find out the ratio PE by QE, and it is coming out to be 8 by 9, and we'll also find out the ratio PF by RF. So it is also coming out to be 8 by 9. So since the ratio of PE and QE and PF and RF both is equals to 8 by 9, therefore we can say that EF is parallel to QR. Third one says PQ is equals to 1.28 centimeter, PF is equals to 2.56 centimeter, PE is equals to 0.18 centimeter, and PF is equals to 0.63 centimeter. We'll find out the ratio of PE by EQ, which is 9 by 55, and PF by FR is equals to 9 by 55. So we'll find out the ratio, which is coming out to be equal 9 by 55. Hence EF is parallel to QR by basic proportionality theorem. In question number 3, if LM is parallel to CB and LN is parallel to CD, prove that AM by BMB is equals to AN by AD. So what's given over here is LM, this line is parallel to CB. So LM is parallel to CB, and LN is parallel to this one, is parallel to CD right over here. So in triangle ABC, we can see we have two parallel lines. So automatically we can say that AM by MB is equals to AL by LC, isn't it? When we do it, so AM by MB is equals to AL by LC. So we'll write it as point number 1. Now in again triangle ADC or ACD, we can say that since LN is parallel to CD, then we can say AL by LC is equals to AN by ND, right? That will be equation 2. Now if we compare both the equations, what we can say, AL by LC is common in both the equations. So therefore their left hand side will be now equal. So comparing both, we can say AM by MB is equals to AN by AD. Question number 4. In the figure, DE is parallel to AC and DF is parallel to AE. Prove that BF by FE is equals to BE by EC. So it is already given that DE is parallel, right here, DE is parallel to AC. So in triangle ABC, we can say that since these two are parallel by basic proportionality theorem, we can say that BD by DA is equals to BE right over here, BE by EC. Easily we can say that, and we will mark it as 1. Again, by the second condition, it is given DF is equal to or parallel to AE. So we'll choose the triangle ABE. Okay, according to that, what we can say, that since those two are parallel, so by basic proportionality theorem, we can say that BD by DA is equals to BF by FC. Mark it as equation 2. Now compare them. We can see that the term BD by DA is common in both the equations. If we equate it, we will get BE by EC is equals to BF by FE. In question number 5, in the figure, D is parallel to OQ and DF is parallel to OR. So here we can say that DE is parallel to OQ. So if we can say that in triangle POQ, these two are in ratio with this by basic proportionality theorem. Again, it is given that PD is equal to PF, and as because DF and QR are in ratio, therefore PD by DO is equals to PF by FR, right? So we can mark them as equation 1 and 2. After marking that, we can say that by equation 1 and 2 we have PD by DO is equals to PE by EQ, and by equation 2 we have PD by DO is equals to PF by FR. So we can say that by equation 1 and 2 PE by EQ is equals to PF by FR, because both equation 1 and 2 has a common ratio which is PD by DO, right? So from this particular observation, we can see that PE by EQ is equals to PF by FR. So now let us focus on triangle PQR. So in triangle PQR, what can we say? That PE by EQ is equals to PF by FR. We have just got the value right over here. Okay. Therefore, by converse of basic proportionality theorem, we can say that the points joining them EF and QR are parallel. Okay. So therefore, by basic converse of basic proportionality theorem, EF is parallel to QR. In the next question, we have a diagram where A, B and C are the points on the top on OP, OQ and OR respectively, such that AB is parallel to PQ and AC is parallel to PR. Show that BC is parallel to QR. So if we focus on this particular diagram, what we can see is that it is given AB is already parallel to PQ. So we can use the basic proportionality theorem in triangle OPQ. Again, it is also given AC is parallel to PR. We can use the same basic proportionality theorem in triangle POR. Okay, and if we do it, then we will get the two equations 1 and 2. By equation 1 we can say OA by AP is equal to OB by BQ, and by equation 2 we can say OA by AP is equals to OC by CR. When we compare equation 1 and 2, what do we get? We have seen that we can see that OA by AP is common to both the equations. Therefore, we can ultimately write that OB by BQ, right over here, OB by BQ is equal to OC by CR, right? Comparing equation 1 and 2. Now, if we look into the diagram again, okay, and focus on the part OQR, okay? If we focus in this part OQR, what can we see? That we can see that OB by BQ is equals to OC by CR, right? So now in a triangle, if we see that this is the scenario, then by converse of basic proportionality theorem, we can say that BC is parallel to QR. Okay, so that's the solution. Question number 7 says, using basic proportionality theorem, prove that a line drawn through the midpoints of one side of a triangle parallel to another side bisects the third side. Recall that you have proved it in class 9. So before anything, let us consider a triangle ABC where D and E are 2 points. So we have to prove that a line drawn through the midpoint of one side of a triangle. So here let us consider that D is the midpoint of AB such that AD is equals to DB. So we can consider AD is equals to DB because we have considered D as the midpoint. Now through D we are passing a line which is parallel to BC. So DE is parallel to BC. We have to prove that E is the midpoint of AC. This is the midpoint theorem. I hope we recall that. So we have to prove the midpoint theorem using the basic proportionality theorem. To prove that, we already have taken D as the midpoint of AB. Therefore, we can say AD is equals to DB. And if we mark it as in terms of ratio, then if we bring the right hand side of the equation dB to the left hand side, then it will come to the denominator. So ultimately we'll have AD by BD is equals to 1. Mark it as equation 1. In equation ABC, we already know that DE is given as parallel to BC. Since these two are parallel, now we can use the basic proportionality theorem in triangle ABC. So by that, we can write AD by DB is equals to AE by EC. Now, we already know the value of AD by DB by equation 1. Let us put the value right over here. If we put the value of AD by DB as 1 in this equation, we find that AE by EC is equals to 1. If we further simplify it, we'll get AE is equals to EC. Hence, if AE is equal to EC, then what we can say that E is the midpoint of AC. Hence, we have proved what has been asked for. Question number 8. Using converse of basic proportionality theorem, prove that the line joining the midpoints of any two sides of a triangle is parallel to the third side. Okay. So in this case, it is given that D and E are midpoints of the triangle ABC. So we can easily write AD is equals to DB. And here, since E is the midpoint, AE is equals to EC. We'll write so. After writing that, let's prove. So since D is the midpoint, AD is equals to DB. Now, just like the previous sum, we will bring the right hand side to the left hand side and therefore it will become the denominator. So we'll get AD by BD is equal to 1. Let us mark it as equation 1. Also, E is the midpoint of AC. So we'll also get AE is equals to EC. So again, just like the previous step, AE by EC is equals to 1. Mark it as equation 2. Now, from equation 1 and 2 on the right hand side of both equation 1 and 2, what do we have? 1. Since on the right hand side we have 1, so we can equate equation 1 and 2 and we will get it as AD by BD is equals to AE by EC. So, if we get the ratio as AD by BD is equals to AE by EC. This is our converse of basic proportionality theorem, right? So if we are dividing a triangle with a line and get the sides of the triangle in a ratio or proportion, then we can say this line will be parallel to the base of the triangle BC. So hence, by converse of basic proportionality theorem, we can say DE will be parallel to BC. So, in question number 9, ABCD is a trapezium in which AB is parallel to DC and its diagonals intersect each other at the point O. Show that AO by BO is equals to CO by DO. To solve the question, first we have to focus on the given conditions. So first of all, it is a trapezium where AB is parallel to DC. So here AB is parallel to DC. Fine. Secondly, we have to show that AO by BO equals to CO by DO. So here AO by BO. So they are not on a line, but we have CO by DO. So for that, what we should consider is, we will consider the line AC and the line BD. Okay, along the line AC and the line BD, we have point O as the intersection. So we'll construct a line which will pass through these lines through O. Okay, and it will be parallel to AB and CD. So we have constructed here EO, which is parallel to AB, parallel to DC, and also passing through point O. So now we have to prove AO by BO equals to CO by DO. We have made the construction, and now let's focus on the triangle which has these two lines, AC and BD, and also EO through it. So we can see triangle ABD has the side BD, from where we can get BO and DO, and it also has EO passing through O through it. So from triangle ADC we can do the same thing. In triangle ADC we have AC, which is a combination of AO and OC, which also has this constructed line OE in it. So in triangle ADC, since EO is parallel to DC by basic proportionality theorem, we can say that AE by ED is equal to BO by DO, right? And in ADC, AE by ED, we have AO by OC. We'll mark it as equation 1. Now in triangle ABD, in triangle ABD we have OE parallel to AB, right? OE is parallel to AB. So in such case we can write down DE by EA is equals to DO by OB. So mark it as equation 2. So by equation 1 and equation 2, we can see there is the same thing, which is AE by ED. In equation 1, it is AE by ED, but in equation 2, it is in the reverse form, DE by AE. So we have to invert it, okay? So DE by EA is given as DO by BO. So therefore, if we inverse it or invert it, we will get AE by DE will become BO by DO. Now we will put the value in the next step. So now compare equation 1 and 2, we get AO by CO is equals to BO by DO. Now just rearrange as it is given in the question. We have got the answer. In question number 10, we have the diagonals of a quadrilateral ABCD intersect each other at the point O, such that AO by BO is equals to CO by DO. Show that ABCD is a trapezium. This is just the opposite or converse of the previous question. In the previous question, they have informed that we have a trapezium and from there we have to prove the ratio. But here it is given the ratio is true and we have to prove it to be a trapezium. So, what is a trapezium? A trapezium is such a quadrilateral whose one pair of sides, opposite sides, will be parallel to each other. So, for that, let us again construct EO for this question. So, after constructing in triangle DAB, in this particular triangle DAB, we can write that EO is parallel to AB. Of course, these two are parallel to AB. Now, from here, by basic proportionality theorem, as EO is parallel to AB, we can write DE by EA is equals to DO by OB. We have marked it as equation 1. Next, here is the given condition. AO by BO is equals to CO by DO as it is given in the question. We will bring it in the form where we can bring it in terms of a straight line. And we will also focus on this particular area, DO by OB. So in the question, it is given AO by BO is equals to CO by DO. This implies AO by CO is equals to BO by DO. We have just interchanged BO and OC. So B from the left hand side went to the opposite side and went to the numerator. And CO went to the opposite side and came to the denominator. Now the question may arise why we are doing so. If we focus on equation 1, we have got DO by BO. That is DO and BO constructs the line DB. Okay? And we have another line AC right over here, which are parts whose parts are OC and OA. So since OD and OB are together in equation 1, we will try to bring AO and OC together in the next step. That's why we are bringing OB and OC to the opposite sides. Next, here we will simply invert the situation. CO by AO is equal to DO by OB. So, here we have again rewritten it properly and marked it as equation 2. The entire purpose of this is to match with equation 1. In equation 1, we already have DO by BO. By equation 1 and 2, what we can see right over here is by 1, we can say DE by EA is equals to DO by OB. And by equation 2, DO by OB is equals to CO by AO. So, we can write DE by EA is equals to CO by AO. Okay. Now, if DE by EA is equals to CO by AO, that means the line EO is breaking it into proportion. The line AD and CA is broken into equal proportions. Therefore, we can say EO will be parallel to DC. These two will be parallel to each other by converse of basic proportionality theorem. We have to keep in mind the result of it. Then only we can solve this sum. So since we have already proven that EO or considered EO is parallel to AB, EO was parallel to AB. Now we have proven in this part that EO is parallel to DC. So therefore we can say that AB is parallel to DC. Now if AD and DC are parallel to each other, that means if these two are parallel to each other, we have a quadrilateral ABCD whose one pair of opposite side is parallel. Hence, it will be a trapezium. So, this is the end of this exercise.